here, okay. And just, can you see my
Yeah,
screen?
Yeah.
yeah,
Perfect.
yeah,
So,
ready.
hey everyone, my name is Ziv, and welcome to my talk, Shifting Left Performance Testing Using K6. So, let me start with a short story. A couple of years ago, I found myself in the heart of Israel working with a forward-thinking company, their specialty on UAVs, which is unmanned air vehicle. And those are not the toys that you see kids playing in the parks. Those are high-end technology advanced drones designed for professional use. My team was basically building those kind of UAVs from composite materials such as fiberglass, carbon, Kevlar, and more interesting technologies. But creating them was only half of the work. It's the true challenge around those UAVs was to make them strong enough to hold the UAV in the air. So it's not me there, but as you can see, every wing of the UAVs had to be tested for strength. We used to place different weights on the different parts of the wing to measure, to validate the wing is strong enough to hold the UAV in the air, because we don't want to have some kind of air crash. So besides building, we used to test it, every part and part before make it fly. So would you feel safe boarding a plane if you knew that the wings were not only tested mid-flight? I guess most of you not. So why are we feeling okay that we are testing our software on terms of performance only on production? So my name is Ziv. Although my last name is Calderon, I was born and raised in Israel. I've been working in active fence, which basically were helping platforms to make sure their trust and safety policy is making safe, so their users are not uploading malicious content or violative content on their platforms. So we are using AI models to detect those kind of stuff and helping their trust and safety moderators to be more efficient there. I love to code, run sourdough bread and pizzas, and in the last couple of months I'm part of the K6 champion um, community, which is amazing. So hi guys from K6 as well. Oh no, not the pager duty again. System latency, Kafka lagging, DB query. Oh no. Again, performance on production. So it's not true. Okay, it's a fake one. So let me start from the end. Load testing is not difficult. Okay, I hope to convince you in the upcoming 25 minutes. And why shifting left performance test, and why I think KSIC is the right tool for it. Nowadays, modern systems are complicated. As you can see, it's a really high level architecture. On the left side, you can see the client apps. We have the mobile, we have the desktop application, single page app, back office, etc. On the right side, it's even worse. The entire backend, different microservices, different database. We have the event bus, the queues, the Kafka, the Rabbit. Such a mess. And when the user is, I don't know, paying something, so many events is happening in the system, and there are so many different kind of problems that may occur, especially when we're facing with performance. Now, I really like this graph because it demonstrates how front end in terms of response time keep the same in terms of latency, but as much as we have concurrent users, it's affecting mostly around the backend Okay, and we are going to focus around the backend, but there are capabilities now of browser to run performance tests, which is super cool, and you can find, but I'm not going to focus again. The major problem is the number of concurrent users are mainly affecting the backend response time. Now, I asked myself, is load equals to performance test? And I was not sure, so I asked ChatGPT, and he answered no. Load and performance tests are not necessarily the same thing, although they are related concepts. So I guess most of you are familiar with the right side. It's the sign on the elevator. In my building, we say we allow 4-person max, which is 1,000 kilogram or 1 horse or 5,050 bananas, hens, eggs, pigeons, haddock, nickels, different kind of measurement. Now, load testing is the process of putting demand on a system and measuring its response. Okay, it's according to Wikipedia. Basically, the system in the right is the elevator, and putting demand is basically, we say we allow up to 1,000 kilogram. Okay, what happened in 2,000 kilogram? Great question. I get it. I'm not sure it was tested. And we have 4 major different types of performance tests. We have the load testing, which again, putting the load, the demand. We have the stress testing, okay, as you can see in the line here. In the case of the elevator, putting 1,500, 2,000, 2,500, when it started to break. We have the spike testing. Let's say Black Friday, or we have some kind of event that we really want to go and we are pressing refresh. So it's making a spike to our system. And we have the soak, the long duration tests, many around finding the memory leaks and stuff like this. So we're basically checking how the system handled the expected traffic. Do we meet the goals or not? What kind of failure mode we have? Okay, again, let's say the elevator. What will happen in 2,000 kilogram? Is it going to crash and all the, I don't know, weights are going to fall? And how does the performance of the system change over time? Again, memory leaks and etc. Some few words about shifting left. I know that it was mentioned on the session before. So shifting left is basically if we're taking the entire life cycle of development. We have the planning, coding, building, testing, then release, deploy, operate, monitor, and it goes forever. Okay, so when we are shifting left our parts, okay, in this case the performance test, we basically checking the performance before the release, okay, comparing to checking it after or not to checking it at all is I guess will happen on production, which is the right side. So shift left is the practice of moving testing, quality and performance evaluation early in the development process. Often before any code is written, shift left testing helps teams anticipate changes that arise during the development process that can affect performance or other delivery process. This is a quote from Saif Gunja from Dynatrace. And I really like this graph because it basically shows us how much attention we put on quality on the different phase of the software lifecycle. Okay, when we plan and design, we put less attention. We don't have the code yet. Then we develop and build. We have more attention. Okay, unit testing, for example. And we go up to the right to the deploy and release. Now, the interesting part is this line is how much is cost the error. Okay, as long as we are getting into production, the price will be much higher than find it earlier. In our case, we're performing two performance tests. Okay, one is once we finish to build and develop our part, mainly around a microservice in this case. And when we are dealing with end-to-end testing, we have a suite of performance tests that we want to make sure that we're still meeting our goals. And let's get into the point. Load testing 101. So we're going to cover four major parts. We have the planning, which is in general, we're going to talk about how we plan the load test. And then we will make the test, okay, and execute it and analyze the results. Those three steps are going to be on K6, but again, there are other tools that can fit. We choose, my team and my company choose K6, and I'm going to elaborate about it. So let's start with planning. We must have goals. Like every other task, we must know what are the expected results. When we're talking about goals in terms of performance, it's called SLO and SLI. SLO is basically the service level objective, and the SLI is the service level indicator. Let's say as our SLO is having an uptime of 99.9 percentile. The SLI is how do we count, how do we measure uptime? If it's the error code, if it's by response time, and etc. Those things are basically the parts that we're going to measure and codify after it. The next part is keys. Keep it simple. It's really hard to make a really long scenarios. Let's say login, do X, do Y, do Z, and then measure it as end-to-end. Try to measure when you're focusing on performance, try to measure the critical parts and try to be really focused around it. And the last part is, where are we going to test it? We can test it in production, again, like the UAV in the air. And I'm less recommended. It might also affect other users if you are on a SaaS, or a dedicated environment such as development, staging, etc. But in this case, you need to make sure those environments have the ability, have the same resources as production. Otherwise, it won't simulate. Another part is the amount of data. Let's say in production, we have a table of 1 million rows, and part of our scenario is making a query based on those tables. So we want to simulate the amount of data like in production, otherwise it won't really help us. And now for the party, K6. So let me play. We don't have sound. It's a really nice video from their website. So it's an open source since 2016, originally called Speedboat. Nowadays, there are 21.4K stars on GitHub. It's acquired by Grafana in 2021. It's written and implemented in Go, although we're going to script it in JavaScript. And we have multiple execution modes, such as local, which what I'm going to do, distributed, like Kubernetes. This is basically what we are doing in my company. And we also have the K6 cloud, basically someone else's machine in order to run those load tests. By the way, K6 is it's in order to say Capaballo. It's K plus 6 letter. You can Google it later. So a few more words. Again, it's implemented in Go. It's using an open source called Goja, which basically getting a JavaScript and run it on a Go engine. The installation is really simple, and I encourage all of you to enter into the documentation of K6. It's pretty clear. Really depends on your operating system and where you want to install, so I'm going to skip the installation, but again, you must install it. And let's jump into the, I don't know, the interesting part, the test case creation. So we're going to write the JavaScript, then we're going to codify the goals, run it, and analyze the results. Okay, we're going to cover all of it, and we are going to writing a few different scenarios and flows, and I will you can see. Okay, it's going to be a live session. Short terminology, because it's really critical for understanding K6 better. VU is basically virtual users, are the number of virtual users that are going to execute as many iterations as possible for a specific amount of time. The duration is the total duration of running a step, and stages is basically ramp up and down the number of virtual users. Okay, so basically, this is our way to control what are the load that are going to be on the system. Let's see how our script is going to look like. So there are two first part. We have the setup and the tear down. Basically allows us to inject data, scale up the system, I don't know, stuff that we want to do before running the steps. The test is going to be called once. And once the test is end, we are going to call the tear down. Okay, again, deleting data and etc. The main part, okay, is going to be the method that the virtual user is going to call. If we have 10 virtual users, they are going to be called 10 times in a row, in parallel, sorry. So this code is an example. We basically are going to make a request to test website of K6 and checking the response. Okay, if it's 200, we are okay, and then go to sleep for 1 second. In this case, we are import from two main libs. One are the basic K6 is the check and the sleep. The check is going to be on the report himself. The sleep makes us creating some more user behavior like, and also control the load. And the HTTP, again, it's an HTTP request. There are tons of extensions. You can call, I don't know, Kafka, you can call Rabbit, you can call different API, really tons of extension to make your life easier to run every performance test that you want. So K6, okay, it might be confusing because you see here no JavaScript code, but K6 is not Node.js and not a browser. Don't try to use models from NPM or Windows Object. It might fail. Again, it's a Go. And let's go to the demo. Basic test. Let me know if it's big enough because I'm not really sure. Okay. So the basic test is the one that was you saw earlier. And in order to run it, I'm running K6 run. Okay, it's basically a command of K6. And a flag called VUs, it's the virtual users. I'm going to run 10 virtual users for 10 seconds. And this is the script that I'm going to run. Let's run it. As you can see, a really nice CLI tool, K6, and it's starting to run. You can see number of virtual users, how many requests completed, okay, and how many interrupted, and we are going to cover the results later, but basically what we saw here is 10-second test of 10 virtual users that made around 89 iteration of request. Okay, and now getting into more interesting stuff that we have, because it was pretty basic. The options. It allows us to include stages and scenarios on our JavaScript test. What does it mean? As you can see from row 6 to row 13, I created an option object and the stages. Okay, we will see advanced part of the options. In this case, the stages are going to have duration and target. The duration is how long, the target is how many virtual users. You can see in the graph on the right what we are doing. Again, the test is the same test, making a request to this website. So for the first 10 seconds, we're going to get a target of 10 virtual users. Then in the next 10 seconds, go to 20. Then spend another 10 seconds with this same amount of virtual users, and then scale down the system in 10 seconds. 1 minute. Okay. So now the second part, all the code is going to be available on GitHub. So feel free not to copy it. So I'm going to run it again. In this case, I'm not going to run it using the flags. I'm going to use the option, and again the same thing. So we can see here number of virtual users is going to climb until the 10 second, going to reach into 10, then another 10 seconds climbing into 20 virtual users. This number is the, and here you can see how many requests they did. Now we are staying into 20 up to the 30 seconds, and then it's going to scale down up to 0, 19, 17, 16. Okay, again, you can see now 430 completed iteration. Basically, again, because our main method is pretty simple, we did, in this case, 438 requests into test K6IO. Oh, 1 minute. Okay. So now let's see more advanced options that we have in order to control our performance. So the options give us different executors, such as shared iteration, per virtual user iteration, constant views, ramping views, constant arrival rate, ramping arrival rate, and externally controlled. We have the start time, graceful stop, execution. We can control which method if we have couple. Okay, we want to create different scenarios in different parts, different virtual users. Okay, really depends on what we are trying to run, and basically it gives you full control. So in this case, I created a scenario that start with shared iteration scenario, okay? And then of 10 virtual users, they're going to have 100 iteration, okay? It's going to be shared, so in average, every virtual user is going to run 10 times. Then per virtual user scenario, each virtual user is going to run 10 iterations for 10 seconds. It will start, after 10 seconds. Hopefully this will be ended in 10 seconds. And then we will have a constant arrival rate. I want to have a stable rate of 3 requests per time unit, in this case 1 second. And it will start 20 seconds after for 10 seconds. So scenarios, let's copy. It's the same code that we just saw. As you can see now, every step has its own bar. Okay, so once we will get into 100 requests, it's going to over, okay, 100, 100. And then each virtual user is going to be run 10, in this case, the same 100, and then it's going to be stable, 3 requests per second. Again, the logic of what we're calling really depends on your scenario, and those tools are giving us the option to control the rate. And it's really nice to run it, but what does it mean? What we are seeing here, so many numbers, really confusing. So when we are analyzing our data, we basically we basically measure ourselves from two perspectives. One is the system point of view, is the CPU utilization, the latency, horizontal pod autoscaling, errors, lagging, utilization, and more. And we have the K6 point of view. It's basically how the user experience the results. And we have, when we are dealing with performance, we are usually taking the average, okay, the P50, the P90, that it means that 90% of the requests were less than X. Error rates, response time, and data transfer. So, sorry, okay. So we have this table, basically how many iteration we had, how what is the duration of the request, um, how much data we received, how much data we sent, and virtual users, and etc. So again, those kind of stuff is basically what we are measuring. And threshold, it's going to be really fast, is basically what we gives us the option to codify our results. So in the threshold, again, in the options, we basically putting our SLIs, what we are measuring. Again, if the rate of the request failed is supposed to be less than, what is the expected duration, and those thresholds give us the option to get if the test was good or not. Again, once you have a baseline, it's basically really easy to control, and you will get at the end if it was good or not. So having the option to codify our goal, giving the option to put our data, our load test as part of the CI/CD. So once we have a pull request into production, we can run a unit pull-less integration test. We can deploy in our case to some dedicated environment, running our load test, sending to Slack the report, and if everything is okay in case of the goals, we can deploy to production, and then we are getting a coverage of performance as well. It's improving our reliability, better deployment on performance aspect, and it's much cheaper again to solve those issues before taking to production. The cons, it's cost money to run performance tests, and it takes longer to deploy to production. So load testing, I hope I convinced you, is not so difficult. Again, I hope to convince you why shifting left is doable to run before production and why we love K6. Thank you. Let me stop my screen and